welcome to Math Made Easy by PlanetSpark. My name is Nidhi and I am here to help you out with all of your doubts regarding any topic there for your exams, everybody. So last time, if you have checked the video, we were learning about circles and the properties. Okay. अब हम जो topic start करने वाले हैं, that is quadrilateral. So if you have missed any of the videos there, quickly check the links down below. So let's get started, everybody. तो यहाँ हम डिस्कस करेंगे कुछ important theorems there in the chapter quadrilateral. Let's see here. The midpoint theorem, very important theorem in this chapter, everybody. क्या बोलती है ये theorem? States that the segment joining the midpoints of two sides of a triangle is parallel to the third side and half its length. देखो, proof बहुत ही important है. Right, because you have to remember some construction there which we have to do in order to prove the result there. तो क्या कहती है theorem? हमारे पास एक triangle है, let's say triangle ABC, right? AB और AC के mid points को अगर हम join कर दें, let's say P and Q, then the theorem says that PQ will be parallel to BC and PQ will be half of BC, right? Half its length there. Okay, any triangle you can take, any points you can take there. Okay, so let's try to prove it. For that, what we have to do here, the construction that is, let me tell you, PQ को हम extend करेंगे to, let's say, a point R such that PQ is equal to QR, right? Then simply join RC. That's it. इतना करना है बस. And now you have to take these two triangles. Okay. So now let's take triangle APQ and triangle CRQ. Okay. Now in these two triangles, what do we know? हमें पता है Q midpoint है AC का. That means AQ is equal to QC, everybody. AQ is equal to QC. Then हमने construction ऐसे की है that PQ is equal to QR by construction, right? Then do I see a pair of vertically opposite angle, everybody? Yes, this is a straight line, this is a straight line. Two straight lines intersecting each other. The point of intersection पे क्या होंगे? Vertically opposite angles and they will be equal. So I can say here angle AQP is equal to angle CQR, right? Vertically opposite angles, right? So by which criteria the triangles are congruent, everybody? Quickly tell me in the comments. Yes? Absolutely correct. Side, angle, side. So by SAS criteria, the triangles are congruent. Then by CPCT, कौन से parts चाहिए हमें यहाँ? Let's see. By CPCT, what all do I need? First of all, I can say this AP length will be equal to CR. Yes, everybody? Okay, then AP is equal to CR, right? Then, can I say these two angles will also be equal? Yes, and these two angles will also be equal. But हमें ज़रूरत सिर्फ इनकी है. Why? Angle, let's say PAQ is equal to angle RCQ. अब इन दो angles पे focus करो ज़रा. We have these two lines there. This is acting as a transversal. So they are what? Pair of? Yes, alternate interior angles. और alternate interior angles अगर हमारे पास equal हैं, that makes the lines to be parallel. So from here I can say PA is parallel to RC. PA ही extended हमारे पास AB है, right? So I can say AB is parallel to RC. Right? Now, P is the midpoint here, so AP is equal to PB. अब AP CR के equal है और AP PB के equal है. So I can say PB and CR are equal, right? दो opposite sides parallel and equal है, that makes BCRP to be a parallelogram. So if one pair of opposite side is parallel and equal, I can say the quadrilateral is a parallelogram. So we have got here, let me write, PRCB is a parallelogram, right, everybody? So opposite sides will be parallel there, right? So I can say PQ and BC are parallel. That means PQ parallel to BC. एक चीज prove हो गई that these two sides are parallel. Now we have to prove this is half of BC. Tell me, Q is the midpoint here, PQ and Q are equal है. by construction, and opposite sides of parallelogram are equal. So I can say PR is equal to BC. PR is made up of what? PQ and QR both are equal. So 2 times PQ is equal to BC. That means PQ is equal to what? Half of BC. So both the results are proved here. PQ is parallel to BC and PQ is half of BC. And that is the proof of midpoint theorem, everybody. Just remember the construction. PQ हम extend कर रहे हैं in such a way that PQ and QR are equal. Then just join R and C. Take these through triangles, prove them congruent, and we have our results there. Okay, sometimes यहाँ पे question भी आता है exam में such that you have to prove this to be a parallelogram. Remember the same proof there as well. We can prove this to be a parallelogram. Okay then. Now, the theorem uses midpoint properties and triangle congruence to establish the equal segments and parallel lines. That's what we have done here. Let's move ahead then. Okay. It is commonly used to prove parallel lines, equal sides, and to identify parallelograms in composite figures. Where do we use it? Yes. Just for triangles? No. Parallelograms के लिए भी हम use कर सकते हैं. Other quadrilaterals also. For example, trapezium अगर हमें prove करना है. Similar way, अगर एक pair of opposite side को we can prove to be parallel, we can say the shape is a trapezium, right, in a quadrilateral. So just be very attentive that in composite figures, more than one figure is there, तो कहाँ कौन सा part we can use there. Okay, then the theorem helps simplify the complex shape by forming a smaller similar triangle inside the original one. Sometimes we can do that as well, right? Let's say this is a triangle. All the midpoints of the 3 sides we are joining here. So the smaller triangle we are getting. This will be similar to the triangle that we have here. Now similarity ka concept we can prove easily, right? If all the 3 angles are equal, then also we can say the triangles are similar, or we can say A similarity. 2 angles equal हैं, तो obviously third angle will be equal by angle sum property, right? So similar means shape is same, but the size is different. For example, I have 2 circles here. So I can say same shape है हमारे पास, size is different. Shape and size both are same, congruence. Just the shape is same, similarity. Remember that. Okay then everybody. Now let's see some questions there. In a triangle PQR, points S and T are the midpoints of the side PQ and PR respectively. Prove that quadrilateral STRQ is a trapezium. Okay then, let's get started. So we need a triangle here. Okay. Let's say this is the triangle that we need. Then the triangle is PQR. Midpoints are given to be S and T. This is S, this is T. Let's join ST. So we have to prove this quadrilateral, right, is a trapezium. क्या prove करना होगा हमें उसके लिए? ST parallel to QR. One pair of opposite side is what? Parallel. So we can say it is a trapezium. Let's do that same proof as we did for the midpoint theorem, everybody. Extended construction in such a way that we have ST is equal to TB. Let's say this point is B. Then join BR. Okay. So now take these 2 triangles, prove them to be congruent, right, by SAS criteria, then by CPCT, right. I can write these 2 sides are equal, these angles are equal, so they are parallel, then we can prove this is a parallelogram. If this is a parallelogram, then ST is parallel to QR and is half of it. Or directly by midpoint theorem you can say ST is parallel to QR and ST is half of it, right. Proof हमें करना है, so write the proof there. Then we can say in this quadrilateral, in STRQ, we have ST parallel to QR. Hence, it is a trapezium. And that's it. Okay, next one everybody. In a triangle XYZ, points M and O are the midpoints of sides XY, YZ and ZX. Okay, let's have a triangle again here. And then we have to take the midpoints there. So this is X, Y, Z. Okay, then M and O are the midpoints. M, N and O. Then we are joining them and we are getting a triangle here. Okay, we have to prove that the area is 1/4 of the triangle of XYZ. Okay then. So by midpoint theorem, we can write, yes everybody, that MO is half of YZ, isn't that? So just apply the midpoint theorem here by midpoint theorem. एक बार हम कंसिडर करेंगे M and O as the midpoints of these two sides and this is the base there. Then consider these two midpoints and this is the base, so we can write the relationship between ON and XY. Then consider this side and this side, so M and N are the midpoints there, right? Same thing we are using thrice here. So I can write here OM is equal to half of YZ, then ON is equal to half of XY, then Mn is equal to half of xz, right? So can I write the ratio of the sides here, everybody? Yes, OM by YZ is equal to ON by XY is equal to Mn by XZ is equal to 1 by 2, right? Ab similarity mein there is a criteria that if we have the ratio of the sides, from there we can find the ratio of the areas. How? Area of triangle XYZ upon area of triangle MNO, that is given by the square of the ratio of its sides. Any sides you can take there, right? Ratio is the same. So I can say I am taking OM and YZ here. So YZ, take the reverse ratio as I have taken XY above there. Okay then. XY, OM, right? This triangle, so side of it, this triangle only, right? XYZ triangle है तो side भी उसी की लेंगे. So I can say the ratio of the areas will be what? This ratio is what? 2 by 1, square of that, so 4 by 1, right? Or if you want to write the ratio of the smaller triangle to the bigger one, that will be 1:4, right? So what is the ratio, everybody? The ratio of the area of triangle MNO to that of XYZ is 1:4, and that is the answer. So just remember this property, right? This is how we can relate in similar figures there. Similar figures are there because they have the ratio of the sides same. Okay, next one. In a parallelogram ABCD, E and F are the midpoints of the side AB and CD. Okay then, we have a parallelogram here, ABCD. Okay then, E and F are the midpoints of side AB and CD. AB and CD, so this is E, this is F. If AC and BD intersect at O, okay, AC and BD intersect at a point O here, prove that EF bisects AC and BD. So, EF bisect इसे तब करेगा when they are intersecting at the same point. It passes through that point of intersection O there. Okay then. So what we have to prove here is that AO is equal to OC and OD is equal to OB. That means O is the midpoint for both of the diagonals there. That is what we have to prove here. Okay then. So we have a parallelogram here, everybody, right? Parallelogram is given, that means the opposite sides are parallel and equal. So if we have the midpoints there, we can say these two are equal. All four of them will be equal, right? Now, can we use the midpoint theorem here? No. But converse of midpoint theorem we can use here, right, everybody? How? We have here AD parallel to CB, opposite sides of parallelogram. Then the line segment that we are getting by joining the midpoints there, it will be parallel to that also. They all will be parallel, isn't that? AD parallel to EF parallel to BC, right? Now look at this triangle. Triangle ABC. Okay, let me highlight this for you. This is the triangle we are talking about. Now in this triangle, E is the midpoint that is given and these two are parallel. So if we have one midpoint and the sides are parallel, we can say this will also be a midpoint here. Yes, everybody. By converse of midpoint theorem. Right? So I can say O is the midpoint of AC. Right? So I can say O is equal to OC. One thing is proved. Then consider another triangle here, right? Let's say now I am taking triangle ACD. In triangle ACD, same thing. We have a midpoint. These two are parallel. So by converse of midpoint theorem, O is the midpoint. Okay. Yeah, same thing we are getting there. So let's take this triangle instead. Okay. That is triangle BCD. So in triangle BCD, again, F is the midpoint and these two sides are parallel. So I can say O is the midpoint for BD there. That means BO is equal to DO there. O is the midpoint for the other diagonal as well, right? So what have we proved here? That O is the midpoint for both the diagonals there. So we can say that is the point of intersection of EF as well. That means EF is bisecting both the diagonals here. Hence proved there. तो क्या अप्लाई किया है हमने? Just the converse of midpoint theorem twice, and that's it. Okay. Next one, everybody. Next question, everybody. A trapezium ABCD has AB parallel to DC and E and F are the midpoints of AD and BC. Okay, so let's say this is the required trapezium. These are the midpoints given, right? Now, to prove that EF is parallel to AB and EF is half of AB plus DC, a construction हम करेंगे, that is just extend BP there in such a way that you can join extended DF to it. That's it. Right? Now, what do we see here? These two triangles. In these two triangles, let's see if we can prove them to be congruent. Right? What do I know? That F is the midpoint here. That means BF is equal to FC. So, let's say in triangle FBP and triangle FCD, what all do we have? We have BF is equal to CF, everybody. F is the midpoint. Then, one pair of vertically opposite angle we have, right? So, angle BFP is equal to angle DFC. Then, AB and DC are parallel. That is given to me, right? So, AP will also be parallel to DC. Extend ही तो किया है हमने उस line को, right? So, when we have two lines parallel, I can say the pair of alternate interior angles will be equal. Absolutely. So, I can say here angle 1 and angle 2 are equal. Yes, alternate interior angles, right? So, by which criteria the triangles are congruent, everybody? Quickly tell me in the comments. Yes, by AAS criteria. If two angles of triangles are equal to the angles of the other triangle, all three will be equal, right? So, we can say by AAS criteria the triangles are congruent. Okay then. So, by CPCT, what all we can write? The rest two sides are equal, everybody. So, I can write DF is equal to FP. Right? That means F is the midpoint of this side as well. Then I can write this pair of angle to be equal and these two sides also equal. That is BP is equal to DC. Right? Let's see from here how we prove the result. EF is parallel to AB. So for that, just join EF. Right? Now look at this triangle. Right? Let me isolate it for you. This is the triangle. And these are the midpoints joined of the opposite sides. E एक midpoint है. And from here we have got that F is also the midpoint of DP. Right? So look at this triangle. Can I apply midpoint theorem here? Midpoints are joined using a straight line. So I can say these two sides are parallel and it will be half of it. Isn't that, everybody? So let's do that. So by applying midpoint theorem in triangle DPA by midpoint theorem, I can say EF is parallel to AB and EF is equal to half of AP. Right, everybody? If it's parallel to AP, that means it's parallel to AB also. So directly I have written parallel to AB. Now, AP is what? AP is, yes, everybody, AB plus BP. And BP किसके equal है? Yes, BP is equal to DC. So I can write here half of AB plus DC. Isn't that the result that we have to prove here? Half of AB plus DC, right? Then parallel to DC कैसे prove करेंगे हम? Yes, if it's parallel to AB, it will be parallel to DC as well, right? Because AB and DC both are parallel. So all these three lines will be parallel. So both the results are proved, everybody. And that's it. Next question then. Okay. In triangle PQR, M and N are the midpoints there. Okay. So let's take a triangle PQR. M and N are the midpoints. Okay then. QR is 8 centimeters. Then prove that the line segment MN is parallel to QR and find the length of MN. Very easy. Same as the proof of the, yes, midpoint theorem. Construction karenge, it's a parallelogram, so we can prove they are parallel, right? So just the same as the proof of midpoint theorem. Okay, so I'm not writing it again. You have to write it again, right? So by midpoint theorem, we can say MP is parallel to QR. One thing is proved. Then about the length, what do we know? MP is half of QR. QR की length हमें given है. That is 8 centimeters. So MP will be what? Half of it. That is 4 centimeters. Right? MN. And that is the right answer. This is MN. Okay. Next one, everybody. Okay, that is all. Let's quickly summarize what we learned today, everybody. So, the midpoint theorem, that is very important theorem, states that this line segment joining the midpoints of two sides of the triangle is parallel to the third one and is half in the length there. Then in a triangle, if D and E are the midpoints there, then DE is parallel to BC and DE is half of BC. So, what do we use this theorem for? Yes, in so many cases where we have to prove the sides of opposite sides of the quadrilateral are equal and parallel. There also we use it, right? In the midpoint theorem, if you remember the proof, there we proved that this is a parallelogram and this is a trapezium, right? By joining the midpoints, the smaller similar triangle are formed and making it useful to prove the parallelogram in composite figures, right? Now, remember this kind of triangle we had there? So, the smaller triangle is similar to the bigger one. So, we can use that result to write the relationship in the areas. Also, this portion you can prove to be a parallelogram. Similarly, this one and this one. How? That is what you are going to tell me in the comments, everybody. So, quickly tell me what all you are going to use there, the steps that you are going to use to prove it to be a parallelogram. Okay then everybody, that was all for today. Thank you very much. Join me in the next video and tell me what do you want to learn next. Thank you. Bye-bye. Take care.